Welcome to GRC 377 Web and Print Publishing screencast of The History of the Graphic Arts, Episode 2, Materials and Methods. This will look at the period 1000 to 1500 AD, in which production of printing materials such as paper and ink expanded, and the invention that dramatically influenced how we communicate today. During the first part of the last millennium, saw the increased development of processes and volume production of materials necessary for printing, including paper and ink. Also saw the development of printing methods, more efficient, and more exacting, and with better quality. Expanding on methods of paper making, now with use of large vats, is documented both in Italy and Germany by 1400. Volume making of paper allowed and spread for rapidly printing of letters, records, old master prints, and popular books and manuscripts, using primarily woodblock printing. The paper-making technique, or secret, had made its way from Asia to Europe by way of trade routes and the conquest of attempts of the Moors from northern Africa into Western Europe. Ink, the other raw material of printing, was largely a product produced by the printer himself. It would be a couple hundred more years before ink factories would produce ink in volume. It would be the invention of printing from movable type that would shape how printing was for the next few hundred years, but more dramatically affect how humans communicate. In fact, it is credited with bringing Europe out of the Dark Ages into the Renaissance. Johannes Gutenberg, born in Mainz, Germany, was a goldsmith and printer who is credited with inventing printing from movable type in Europe about 1437. Gutenberg's method for making type included using melted metal alloy and a hand mold in which the type was cast. The individual characters could be assembled into rows within a frame known as a chase, inked and printed from. The type then could be reassembled later for other printing, unlike woodblock printing of the time, in which once made could only be used for that particular printing. The use of movable type was a marked improvement on the handwritten manuscript, which was the existing method of book production in Europe by writing calligraphy by hand. Now it was possible to speed up the process without sacrificing quality. His major work, the Gutenberg Bible, also known as the 42-line Bible, it had 42 lines of text evenly spaced in 2 columns, has been acclaimed for its high aesthetic quality and technical innovation. Pope Pius II said in 1455 that a marvelous man had been promoting a printed Bible and that he had seen parts of it, and it had such neat lettering that one could read it without glasses. In addition to Gutenberg's design of metal movable type, he also developed the use of oil-based ink and created a wooden printing press similar to the screw, olive, and wine presses of the period. The combination of these elements resulted in a practical printing system that revolutionized European bookmaking. Gutenberg's printing technology spread rapidly throughout Europe and greatly facilitated the spread of knowledge and is considered a key factor in the European Renaissance. Ironically, things were not as good as one might expect for Gutenberg. Among other things, he had a financial dispute with Johann Faust, his partner and financier, on the joint work on the Bible, which ended in a court case that got him into serious financial difficulties, resulting in defaults on debts. Gutenberg was named Man of the Last 1,000 Years by Time magazine. Let's watch a recreation of Gutenberg in action.
We only pick it up again in Strasbourg, where he settled in 1434. Here he set up a factory that produced mirrors for pilgrims. These were very popular among the faithful, who hoped thereby to capture something of the charisma emanating from the shrine they were visiting. and from the relics it contained. For Gutenberg, it was a lucrative business. There was a flourishing trade in devotional objects. Particularly popular were woodcuts depicting the saints. Woodcut is one of the earliest printing techniques, but it only reached Europe in the early Middle Ages. Here it served primarily for the dissemination of pictures and texts. But cutting these whole-page blocks is a time-consuming process. First, a mirror image of the handwritten page has to be drawn on the block. Then the individual letters have to be carved out. Finally, the block is inked in, and the sheet of paper is laid on top and rubbed hard with a bone tool so that it takes up the ink. By the start of the 15th century, more and more of these page prints were coming onto the market. Occasionally, a number of pages were bound into a book. The trade in these books also gave a boost to manuscript production. Manuscripts had long since ceased to be the exclusive preserve of the monasteries. Secular scribes were doing good business. The establishment of the first universities had created a great demand for books. Libraries were founded, making knowledge in the form of books accessible. Books needed to be cheaper and more quickly available. But that wasn't all. In particular, scholars wanted uniform copies. A new production technique was feverishly sought after. And one of the seekers was Gutenberg. In 1446 he returned to Mainz. Here he found solid financial backers, allowing him to go ahead with his enterprise. His breakthrough came with a brilliant idea. He broke up his text into its constituent parts: letters, punctuation marks, and frequent combinations known as ligatures. These were then combined to form the blocks for printing words, lines, and pages. The characters were cast and could be used in new combinations time and again. A character is produced as follows. On the end of a metal rod, a mirror image of the letter is engraved. This is then pushed into softened copper, producing a pit in the shape of the letter. This matrix, as it's called, acts as the mould for the actual type, which is cast from lead. In order to manufacture the many letters needed quickly and in sufficient quantity, Gutenberg took another important step forward, inventing the hand-casting instrument. It consists of a rectangular channel. The matrix is inserted at one end and molten lead poured into the other. When the instrument is opened, a letter cast in lead is there, ready to be used. As the matrix is reusable, an unlimited number of identical letters can be cast. Finally, the typesetter can begin to combine the letters into lines. In the form, the lines or columns are combined to create the page layout as desired. The result is a mirror image of the page to be printed. The form is now inked in with printer's ink. Gutenberg used a mixture of lampblack, varnish and egg white. Printing can now start. Gutenberg used a special press for this purpose, but he derived the principle from the traditional wine press. Gutenberg's first printed works were official documents, papal decrees, and grammars. But soon he started on a mammoth venture, the Latin Bible. For this project he cast more than 100,000 pieces of type. For more than 2 years, Gutenberg's typesetters and printers worked on the first edition of 180 copies. The text was printed in black letter or Gothic type, based on the handwriting of the day. Finally, the illuminator added the coloured initials and drawings. With his Bible, one of the world's most beautiful printed books, Gutenberg proved that a work printed with movable type could be as aesthetically pleasing as one written by hand. The edition was soon sold out. Gutenberg's contemporaries were impressed. It was the first time a work had been available in such a large edition, and every copy was identical. The written word now had authoritative status.
Certainly, Gutenberg's invention has had a great impact on human communication. Of course, history forgets that a form of printing was being done using ceramic materials around 1040 AD in China, and later with metal type in Korea in 1377. Not to mention the stamps probably used on the Patheos discs discovered in Crete.